Hi everybody, this is Mr. Nolan, and what I would like to do with you in this video is talk to you about how to create geologic cross-sections. So we want to be able to create a geological cross-section based on a story of an area's geological events. So I should be able to hand you basically a story, a written explanation of all these things that happened, and you should be able to come up with a cross-section based on that. These are a little tricky. You're going to need one thing to be successful here, and that's this document. It's called Geology Storytime, using stories to understand geologic cross-sections. And so before we sort of go into this, I do kind of want to give you sort of a bit of a cheat here. To make this easier, I'm going to use this program. This is a program that I showed you in a previous video. The website I'll include in the information section of this video, but it's visiblegeology.com, and so we can create our own geologic profiles. So if you're ever trying to write or to draw a geologic cross-section and you're not really sure how it looks, you can always go on and use this website kind of as a cheat to show you, if you did things in that order, what would actually happen. So what we want to be able to do is to create a geologic cross-section. So in this document, in this Geology Storytime, I include some information, some background information about what different environments result in when it comes to the cross-section. So for instance, if you have a body of water, you're going to get deposition. If you have a terrestrial environment, so the sea level drops, that's when you get erosion, and you get what's called an unconformity. Pressures or tectonic forces can give you faulting with fracturing rocks. Really high pressure and mountain building can create folding, can squash rocks together, so you get these metamorphic folded rocks. Uplift can result in tilting. So layers get tilted. One important note about tilting is that when the rocks tilt, everything underneath them tilts. Everything underneath of those rocks tilt. And also pressure, mountain building is the same way. These are regional processes, so whether it's mountain building or whether it's tilting, these are going to give us processes that affect all the rocks. Folding affects everything under it, and so does tilting. We'll look at what that means in a moment. Any deep volcanic activity is going to give us igneous intrusions, such as dikes and sills, and then volcanoes on the surface are going to give us things like lava flows, right, with extrusions. So on this sheet, there's a number of little stories, little sort of short stories, that you have to try to figure out what the cross-section looked like. So I'm going to do just 3 or 4 examples here, as many as this video allows, and to kind of show you what should these cross-sections look like after we've read the story and created them. One note I want to point out, on this simulator, I'm going to do everything in order, right? I'm going to do everything in the order that it's written here. I'll kind of zoom in a little so you can see better. However, when you're trying to do this by hand, if you're actually trying to draw these, it works best to do them backwards, because the later things are the most recent. They affect everything else. So if you have, for instance, if you have tilting. If tilting is the last thing that happened, that means all the rocks need to be tilted. Or if, the last thing that happens is that you get a dike, you get this igneous intrusion, that dike should actually cut through the whole thing. So we'll just pick a couple of examples here, and we'll do a few of these together. Let's actually start with kind of a simple one. Let's start with this very first one. So we've got an ocean where deposition occurs. We have a diagonal fault that breaks the rocks, and then we have the ocean levels falling that causes the water to recede, which means erosion. The rocks are going to erode, and then later the ocean is going to come back and give us new layers. So let's kind of go in order here. Let's kind of use the simulator to show what should this cross-section look like. So once there was an ocean where deposition occurred. So let's go ahead and take care of that. So let's add some beds. All right. So here's our geologic beds. So this is the first thing that happens, is that we get these layers. So this is now taken care of. Now we get a fault. So there's faulting going on. It's going to fracture the rocks. So in our simulator, let's go ahead and give a fault. So let's find a fault. There it is. I'll just tilt this a little bit. There's our fault. Okay, so we've shifted our layers, so we've got a fault here. That's taken care of. the next thing we need to do, the ocean level falls, so the water receded and the rocks are exposed to the atmosphere. What that means is that we're going to get what's called an unconformity. So let's jump over here, find an unconformity, there it is, and let's make an unconformity. Now notice that the unconformity has already included the fact that our deposition happens later. The ocean returns and deposits new layers. Well, there we go. So what we've really done here is we've gone in order and we've created this cross-section, right, from using our simulator. Now, whether you do this with a simulator or on paper, you should end up with the same exact drawing. You don't have to use color or anything, but we should indicate, okay, I got a fault here, I've got my unconformity, I've got my new layers on top and my old layers on bottom. So let's go ahead and actually add that to our document. Okay, so there's our cross-section. That's what that should look like. Let's look at a couple of others. So let's jump through here. Here's a few more. So once we had an ocean where deposition occurred to produce sedimentary rock. So again, the first thing we're going to do is we're going to create some new layers with deposition. So let's go ahead and refresh this, create some new layers. All right. Here's our new layers. Here we are. And so that's all taken care of. Volcanic activity brought magma near the surface, where now a dike is created. So the next thing we're going to do is we're going to create a dike. So let's find a dike. Again, let's tip it a little. It doesn't really matter if it's tipped or not. Okay, there's our dike. So this is an intrusion, which means we're going to get baked zones there and there, right, on both sides. So there's the dike. That happens next. Take care of that. Later, the ocean receded when ocean levels fell and erosion erased some of the rocks. And then the ocean returned and gave us more rocks. That's talking about an unconformity, right? Anytime that erosion erases some of the rocks, that means that you have an unconformity. So let's add another unconformity. There it is. Okay, we're almost there. And then finally, more volcanic activity produced a sill in the new rock. So a sill is always going to be basically a horizontal dike. So here's a sill. And the sill, it says here that the sill is produced in the new rocks, right? We have to be specific where this is. So we're going to put our sill, maybe here. So we're going to add our sill. And so this is what this should look like. That sill's not very dark, but this is what this one is going to look like. So we've gone through, we've done all of those examples. So let's go ahead and add that one to our document as well. Okay, so right, we should have that drawn also in the document, right? So notice these are really two different events, right? They look kind of similar, but they're pretty different. Let's jump ahead and look at some that are a little bit more advanced. Let's maybe do this one. This is a really interesting one. So we have a few things going on, a lot of tilting. So once there was a shallow ocean where sandstone was deposited. So we have some deposition. So let's go ahead and do some deposition right now. Let's get a new layer, or a new cross-section here. Add some beds. All right, so deposition. Pretty much always the first thing that's going to happen is you're going to get deposition. So that's all taken care of. Then large regional forces cause the layers to tilt. So that's the very next thing that happens here. So let's go ahead and tilt things. Add our tilting event. All right, there it goes. And so here's our new layers, or our tilted layers rather. So that's good. Now the ocean receded and the rocks are exposed. The ocean returned and gave us new layers. Do you remember what that's called? That's an unconformity. So let's go ahead and add an unconformity. There's that. And now here's the weird thing. This says now that the region was tilted again in the opposite direction as before. So let's take care of that now. So let's jump back over here and find tilting. There it is. But now let's tilt it in the opposite direction that it was. So I'm going to kind of just sort of tip this in the other direction. Let's see what happens here. This is going to be really interesting. All right, this is very, very interesting. So what has happened, I want you to notice, this dark blue line, remember, that's the unconformity. And because our layers got tilted first this way and then back that way, the new layers here are what is actually now tilted. The one from before kind of got tilted back. So this really threw off a lot of people while working on this. A lot of you wanted to do this upside down. One thing to keep in mind is that unconformities, the rocks above them, unconformities, always follow the same, they're always parallel to that unconformity. They always follow the same angle. So this is what we're going to get for that example. So let's go ahead and paste that in our document as well. Okay, so that's what that one's going to look like. Let's see. Let's do some folding. Let's go ahead and do some folding. So let's do this one here. We'll do a couple more examples here, one or two. So again, we'll start with once we have our ocean where shale layers were produced. So let's go ahead and get a new one here. New beds. Let's change the color of this one. There we go. Okay, so we've got our beds. Zoom in a little. Those are produced. And this says deep volcanic activity created a sill in the middle of the rocks. So we're going to go ahead and create a sill here. Remember, a sill is just a horizontal dike. So we're going to put our dike in there, or our sill rather. There's our sill. And now this says large-scale tectonic activity created pressure from the sides. That's going to give us something called folding. So let's go ahead and do some folding. Folds, create folding event. All right, so now remember, this dark layer is that sill, right? The sill has now gotten folded because the folding happened after that. And so lastly, there's that. Lastly, new volcanic activity produced a new dike. So this dike, let's add a new dike. Let's give it a little bit of dip. There we go. All right, and so now we have the straight dike going across that folded one in the background. This is what this one's going to look like. So let's add this to our document. We'll do one more example. Okay. Go. We got time for one more. So let's do a real nightmare. Let's do one that's really difficult. Let's do this very last one. This one's a little bit tricky. So we've got a watery environment, and that's the very first thing we're going to start with. So let's get some new beds here. Add our new beds. Go. Okay. So there's our beds. Deep volcanic activity produced a sill in the layers. So let's go ahead and add a sill here. Our horizontal dike. Just kind of put that down here somewhere. Okay, so there's our sill. That's all taken care of. Now local pressures fractured the rock and a diagonal fault shifted the layers. So let's go ahead and put a fault in there. So we're going to fault that. Oops, there we go. There's our faults. Notice that sill is broken, right? Do you see that? The sill is broke. There's that. Later, another diagonal fault occurred next to the first one. So that one's going to happen next to this one. Let's adjust the tilt a little more also. Oops. All right. So that sill has been broken twice. You see that? That's actually broken twice. Now the ocean recedes, exposing the rocks to the atmosphere. That's an unconformity. And then the ocean levels rise again. So let's go ahead and add an unconformity. Right, there's our unconformity. And there's our ocean levels rise again. And now a lava flow happens on top of the rocks. And lastly, more sedimentary rocks were deposited underwater. What that means is really, here's a lava flow. This is going to happen kind of toward the end because this is recent, right? This lava flow is pretty recent, so we'll add this lava flow. That's really an extrusion. And then here's some more sedimentary layers that were deposited on top. So that last example is going to look a bit like this. So let's go ahead and add that to our document. Okay, so even though we didn't do every example here, we at least did enough of them, I think, kind of to illustrate how this process works. You can always use this website in order to kind of cheat a little if you want to confirm and see whether you did it right. But really, if you're going to try to do this by pencil, you kind of have to go backwards. And that's because, for instance, that dike there, that last dike is undisturbed because it was the last thing that happened. So this takes a little bit of practice. It takes some skill. But I hope at least to some extent this video is helpful for helping you figure out how to create geological cross-sections based on the story of an area's geological events.